So in this video, what we're going to try to get through are these first two bullet points. I'm going to give you a brief informal definition of continuity, and then we're going to review graphs of our basic functions. So continuity. Well, if we were actually to define it, what we'd need some concepts and some terms from calculus, but we're not quite there yet. So what we're going to do is we're going to focus on this. In general, this is a very true statement. A function is continuous, therefore continuity. It's continuous over an interval of its domain, our x values, if it is hand-drawn graph, so if you can draw it with your pencil over an interval, can be sketched without lifting the pencil. So basically, if you start at over here on the left of the graph and you start sketching it, and you can draw the entire graph with never lifting up your pencil, that is a continuous function. So that's a continuous function. Lines are continuous functions. All of these are continuous because I can draw them without ever lifting up my pencil. Well, what does it look like when it's not continuous? Well, this function would not be continuous because we're going to draw it. What's going on is we're drawing it here. This open circle means, hey, this part of my graph can't be 2, but when we want the 2, we're jumping right back up here and we go there. So notice we had to pick our pencil up and go here to continue drawing it. That's what a discontinuity is going to look like. And where we are discontinuous is where we had to pick up our pencil. We like to show discontinuous points with an open circle. Open circles, if you have an open circle, we cannot exist at that point. If you have an open circle, you cannot exist at the point. If you have closed circles or lines, that means we exist at that point. The graph cannot exist if it has an open circle, and it does exist if it has a closed circle or a line. So let's look at this one. Let's determine the intervals, the x values, where we are continuous for this function. So continuous means we can sketch it without ever lifting up our pencil. So if we start here and we sketch it, did we ever have to lift up the pencil? And remember, the arrows mean it goes on forever. So on this domain, we are continuous for every aspect of the domain. We are continuous from negative infinity on the left to infinity on the right. So another way to write that is to say we are continuous over all real numbers. Whatever x value I pull in, puts in, gives me a y value that exists, and then we can connect all those values with a single graph. Well, how about this one? So if we start at the left and we start tracing it, we get to that circle. We're not allowed to be that circle. So my pencil has to come up off the page. We're going to get to the other side of the circle, and then we're going to keep going forever. So where do we have continuity on this function? What is the interval for my continuity? Well, we are going to be continuous from negative infinity, the parentheses means don't touch that negative infinity, all the way up until we get to 3. And then we're going to jump over that 3. So we've got our union sign. This is kind of like an and. We're going to go down on the other side of 3 and keep going forever. The parentheses mean something specifically. This is saying start at negative infinity, but don't touch negative infinity. Go to the right until you get to 3. The parenthesis says don't touch 3. Then put your pencil down on 3, but not on 3, on the other side of 3, the right side of 3, and keep going until you get to infinity. Boom. Now, when we talk about our basic shapes, you know what? Actually, what we're going to do here is I am going to stop the video, and we're going to end on talking about continuity. We're going to talk about continuity, and then when we come back, I'm going to do just one video over the shapes of the graph. Alrighty? So if you've got any questions, please jot them down and let me know, and I'll see you when we get into class.